So I'm James Kokoska, CTO at NetAlly, and we're going to talk about a Lambert feature for doing multi-gigabit media qualification. So, I've kind of been in this space, right? I spent 15 years at HP and before they became Agilent doing oscilloscopes and logic analyzers. And then in 95, I went to a startup. We got acquired by Fluke, right? And if you think about 95, it was Token Ring was transitioning to Ethernet, and I came on and basically did the first touchscreen tester. There was 100 megabit. One of the things that is impressive to me is I can still take that same tester from 25 years ago and plug it into a switch, right? A new latest and greatest 10 gig switch, and it'll link up and it'll discover packets and all that. I mean, I think there's a huge testament to be paid to the IEEE, right, for keeping things backwards compatible as opposed to sort of a, go fast and break things. But since I was at Fluke, I was always in this weird relationship, right? So where a large part of the business was in cable certification, and just this weird. But I was on the active network side, right? So just trying to reconcile what's going on between Ethernet speeds and cabling standards, right? And there's sort of this loose association, and you sort of have the IEEE here on the left, right? And they're working on the latest speeds, and that's largely about coding and modulation and a lot of digital signal processing for error and near-end crosstalk, far-end crosstalk, how links train up and negotiate and the resilience there, and then even across the industry, right? The magnetics, right? The transformer on the front end, first thing that you see after the RJ, how linear is that, and how good are the magnetics and the slew rates, and even how do you lay out your PC boards, right? So that's all happening on kind of my side of the shop, right? On the other side, they're kind of chasing twist rates. I mean, there's a magic in taking two pieces of wire and twisting them, but the cable standards have just largely been about twist rates or isolating the twisted pairs, gauges. POE brought in some thermal concerns, but it's some extent it's a bit of a materials and manufacturing game, right? Now, but the problem was that the big build out in networking happened between 95 and let's say 2006, right? Or that's where every building had to have, cabling installed, right? And so the bulk of it was this older CAT5e cabling. So when you look at taking a cable certifier and saying, hey, will my cable pass? So there's application settings in cable certification tools where they automatically take the speed that you're asking for and they equate it to all the underlying parameters that need to pass or fail. So if you would see a screen like this, you would say, my cable will only carry gigabit, right? And so in order to upgrade my AP, I need to pull a new cable, right? And of course, that can be brutal, right? The cost of pulling the cable is likely more than the cost of the AP. A lot of environments, it's just prohibitive. You're going to shut down the office and go through the rafters. Is it a historical site? It's just a mess, right? And so, but you would look at this screen and you would look at passing and failing on certification, cable certification testing, and say, oh, the speed limit for this cable is 1 gig. And in fact, there's a fair amount of misinterpretation in the industry, right? This is actually just saying, no, this is the minimum speed. So in other words, anything will negotiate things. It's more like a warning sign, right? So if you see something like that on the right that says, hey, you can only do 1 gig with that, but a sports car will obviously go, faster than that through the curve, right? And so, not the best analogy I've ever come up with, but you get the idea here. And I was kind of confounded with this, and so I actually reached out to one of the guys on the IEEE NBASE-T standard committee, and he was fairly clear about this. That hey, you know what? It's pretty much misunderstood that this is the max something's going to work at, when in fact it's just the baseline that every PHY must operate on this piece of media at 1 gig. Obviously, digital signal processing has just far exceeded anybody's expectations. I mean, think of your DSL at home. Think of the modulations, the 1024 QAM, right? I mean, it's just amazing stuff. And so, as as we marched on, both from a Wi-Fi standpoint on the top and a wireline standpoint, right? It's really how much stuff can you cram in any moment of time, right? How many bits of information can you cram in there? How dense can you make it? And so, on the wireline side, it went from literally, in fact, if you go back to 10 base T, it was literally just a swing, 0 to 1, right? And then they said, no, we can discriminate 3 levels in there, and then 5 levels, and then 16 levels, and in fact, that's where they are right now, right? In fact, N base T is literally taking the 10 gig wire stuff, 10G base T, keeping the same encoding, PAM16, and saying, we're just going to clock it slower. So 5 gig, we're going to clock it half as fast and a quarter as fast. So that's kind of what's going on. Well, obviously, there's a lot of discriminating a level here, right? As you get to 16 levels crammed within the same voltage swing that used to just be a 1 or a 0, noise is the issue, just like it is in QAM, right? But here again, just the digital signal processing has just advanced so far. So you think about those voltage steps. I found an image of an eye diagram of PAM16. Since I'm an old scope guy, I always think of eye diagrams. But if you look at what happens through the steps of processing here, you basically goes from just what looks like gobbledygook to a clean differentiation of those levels, right? So really, it's SNR that drives the what speeds you run at, right? Whether you're on the wireline side, the image on the right's from MIST, or you're on the wired side, right? And in fact, the wireline side will downshift. Line looks a little noisy. I won't do 10 gig. I'll do 5 gig. That's still not where I want it. I'll do 2.5 gig. We'll shift right down to 100 megabits basically. So I really wanted to set out to understand this and bring some clarity to the market on what's really going on here. So I took the best patch cable I could find, right? This 3M $50 patch cable, and took it. And the test setup is a couple of our tools on the left, right? In this case, you can see the Link Runner 10 gig on the far left, and an Etherscope, and then industry leading cable certifier on the right. And kind of just did some tests. So to level set with just that patch cable, the settings exactly what you saw above, 7-foot patch cable, I basically, we pass. You can see on the left we pass certification for 10 gig. On the right is our feature land birth. So this is a pragmatic thing. This basically says, hey, we're not going to have sort of these second order, parametric things to determine if it's going to carry it. We're just literally going to link up and blast frames at full line rate across, right? And so in 10 seconds, turns out you can blast 142 million frames back and forth across the wire. And so you can see everything looks cool here, right? Now I just take a little bit of a coupler, not certified for 10 gig, and stuck it in the middle, right? Now I'm failing the certification on the left, as you might expect. However, between the two testers, no problem. In fact, this time I ran an hour, right? 51 billion frames back and forth, error-free, no loss, no CRCs, right? So I said, well, how low can we go? Well, since I'm kind of a bunch of junk under my desk. From 1996, when the cable certification industry was just getting started, and I was at Fluke, they had this demo box, and this was CAT5e cabling, if you will, and to demonstrate, because they were trying to show, how cool their new cable certifier was, right? Cable certification was a new thing too, and it was really a means for the cable vendors to ensure that there was a proper installation so they could warranty their cables, right? So it let you understand that the install was good. So they had this thing called a bad install here. And you can see, if you look at the on this back section here, you'll see that it was untwisted towards the end, right? So I dug this thing up and I said, okay, let me take two of these $50 patch cables, and sure enough, right, the TDR picks it up and says check the connector, and you can see some of the reflection here, right at 17 feet, and so obviously we fail. In fact, it will not pass gigabit, but I can take a couple of testers, PHY's devices, anything, and plug it in, and I had no problem linking up at 5 gig. Wouldn't link at 10 gig, but would link at 5 gig, and again could blast millions of frames error free. You can see the SNRs are getting a little low here, but you know what? It got through it. I mean, the PHYs are just miraculous at what they can do, and there's really, and I think it's just added to the gap between cable certification and reality. So and you might be saying, oh no, but you have a tester, right? No. So I said, hey, let me take my it's actually Ruckus switch and NBASE-T switch and run it through the same thing and hook it up to my MUST AP and then actually monitor the port stats and run a bunch of traffic through. No errors, right? No errors, no problem linking up, right? So here I'm taking what was considered a bad piece of cabling in 95, 96 and running 2.5 G base T through it error free, right? I played around with other cases, right? I went out 100 meters again, wouldn't pass on some CAT5e, wouldn't even pass gig because of insertion loss. No problem blasting frames through it. Went through a variety of different APs through this 100 meters of cable into a variety of different NBASE-T switches in our lab, and again error free, right? So it's obvious there's a big difference between what cable certification would tell you. No, you need to rip out this cabling before you install the AP, and what the modern PHYs and the IEEE is actually capable of. So the summary was basically, a lot of times when I failed on certification, but for my pure clean cable case, and had no problem passing frames on Lambert, and in fact, and then circled back and verified that even with NBASE-T. So now what you do need to worry about on NBASE-T, and really the concern all along was noise, right? We talked about this, PAM16 and 133 millivolts between discernible signal levels. That's pretty tight, right? So, and you can see it if you go back and you read through the minutes of the IEEE, the BZ task force, right, that was developing this. It was all about noise, right? What's the test bed for noise? How are we going to do this? How are we going to, what's going on? And I thought one of the coolest studies there was done by Quantia, and it was on ESD, right? And literally, it just came down to the fact that, just getting in out of a chair can throw a pretty good ESD shock a pretty far distance, and you need to look out for that. So we'd actually experienced some of this, not ESD, but EMF, back when we were first bringing the Ethoscope online, understanding, we'd run these, is our hardware good, right? Let's run 10 gigabit. Let's run 10 gigabits through it for a week, right? And at full line rate, and we started seeing these weird errors showing up, and I could reproduce it here with this our little ESD gun, right, for testing that you can shock anything and won't break it. But actually, turned out this air conditioner above our ESD test bed actually was sending out a pulse whenever it turned on, and we picked that up. So, in fact, I even noticed it here. I was at home, right, and running through my little bad install testing and everything, and at one point was running a 1 hour test and noticed, wow, I'm getting some loss. What's going on, right? Turned out it was me getting in and out of my chair, and in fact, it kind of started to look like, hey, when you get out, you actually get some disruption over 1 second. You get actually 2 seconds of some disruption, and not huge, but it is a lost frame, and then sitting down is less, right? So ESD is a thing.
James?
Yes, sir.
Okay.
I'm sorry to interrupt. Really interesting stuff. One question I have is related to PoE. Are you guys monitoring PoE while you do all of this, or is it just purely just data being sent, received. You're looking if you can successfully receive the frames, and that's about it.
Yeah, no, actually, I did a bunch of PoE stuff too, and my take is it takes a lot to drop voltage below the levels, right? In fact, I went through 350 feet of cabling, and I was still at 70 watts, right? The class 8 was dropping to like 47 volts. I've got a whole nother presentation on PoE and voltage drops, but I think at the end of the day, I think I wouldn't worry so much about PoE. I wouldn't worry so much about it linking and being error free. I would just worry about ESD. Is probably the biggest thing in deploying your new N-base-T APs over existing cabling.
Hey James, how much of this are you doing on the silicon of the Ethernet controller? Meaning, can you do this just using anybody's off-the-shelf merchant silicone, or how much of this R&D have you put into the product specific around the controller, the software, and all the pieces that come together?
Yeah, so we have a variety of things we use, right? This is largely out of the PHY. However, if you need to go up to like layer 2 or layer 3 throughput testing, then we deploy our FPGA.
Okay, so I'm just wondering about how much of these, like when I look at competitive products that are using, a USB-C Ethernet adapter, right? You're not going to get this sort of fidelity out of those types of pieces.
Yeah, I think it's gonna be hard, and you need to get access to the registers. And I tell you what, it was actually one of our engineers just did a miraculous job. It took them about a month and a half to decipher what was coming out of the registers, and because there were actually different register sets for different speeds, and which added to it wasn't just one simple thing. You look at the register maps on these modern PHYs or radios or anything, right? There's just literally thousands of registers.
I notice in all your tests you've got two devices plugged in. To be able to run this test, you have to have a device either side of that cable.
You can if you're testing fiber or copper at 100 meg, you can use a physical loopback, right? Fiber, of course, works because there's two strands and you have a separate TX and RX, right? Once you get to a full duplex thing, right, then you need two active testers. And we have compatibility also with the LinkRunner G2. Will work for testing for running up to 1 gig. In some cases, some telecom gear has the ability to do the loop. I've seen some Ethernet gear has the ability to do loopbacks, like through the management console. If you had that, you could use one tester there also.
I was just going to say, is there any way you could use, say, an NXG and a G2?
Yes, absolutely, yeah. But the G2's only got a 1 gig PHY in it. So, an AirCheck G2.
Sorry, yeah, an AirCheck.
That's actually a great question. Hadn't thought of that. I think it's feasible. Yeah, I'll take a note on that. Thank you.
If I'm testing with two testers, my interest is testing against switch ports. I usually am not certifying a cable. I'm testing to see if the port and the cable as a system are good, or I'm trying to troubleshoot an issue. So how do you recommend, or are you going to cover this? Please let me know. What's your test methodology so that you're testing against a far side, like a N-base-T switch, and how do you test through that?
Yeah. So in that case, we actually have our regular performance test. In fact, kind of what happened was we always had a line rate performance test, right? And in fact, it'll soon be going to 8 streams, and each stream you have your own QoS knobs, right? Layer 2 is VLANs and VLAN priority. Layer 3 is the TOS byte that serve stuff. But so that's the same units will do that too, right? But there you kind of need to you need to manage the MACs need to be a little more discrete, or you need layer 3 routing to get through a switch perhaps, or whatever, right? So that's a full test, but it was just too much for a lot of people. And in fact, you're setting me up for my demo, which is just to show you how simple this is to do, right? However, if your switch does happen to support a loopback, you could you could go into the console and loop it back and use one tester, and then that would include the front end of the switch. But you can easily, we have our normal performance test has always been there for testing through layer 2 and layer 3 switches and routers, and you can still use that. It was just too onerous for folks, and so that's why we built out this purpose-built Lambert app, and I'll show you that in a second. I wanted to test some of this noise stuff, impulse stuff, and so here, of course, work from home, so I grabbed probably the best motor I had, which is this Hobart mixer and KitchenAid, and I just took a 154-foot piece of Cat6 cable and just strung it over it. The metal case is grounded, right? I made sure that it went to earth ground, and so it's fairly shielded, and ran along. And as I changed, you see these little speed controls here. As I changed those speed controls, you could just see, in fact, I was generating errored frames. Frames were lost, frames were errored, right? So you can just kind of see the effect of just having that cable draping over that motor as I throttled through the speeds. So let me get to the demo here. Right, yeah, link runner 10 gig on the left, and here we are and you can see here's the new icon, the new Lambert app, right? And so I'm going to here's one of these highfalutin patch cables, right? And I just carefully pulled the plastic away here, but the shield is intact, the wire's intact, just so I can kind of wiggle it around and get a little bit of mechanical noise going, right? So I'm going to go ahead and plug that into my testers here, and I'm going to come into here. So, like I said, we had this performance app, but there was just a lot there because it was really set up for multi-stream QoS validation across, layer 3 networks, kind of stuff, right? So in this case, I can just come into this guy and say, hey, you know what? I want you to be the loopback. And I can come into this guy's always where I don't want him. And then I can come into this guy and say, hey, I want you to be the generator. Settings, again, very simple, right? There's pages of settings for the LR linear performance test stuff. Here it's basically frame sizes, right? I'll go for the smallest frames because that'll give me the best granularity on errors. I can pick my time period, right? All the way up to 24 hours, including trending. But I'll pick 30 seconds for the sake of demo. And then I said, hey, if there's any error, if I lose any frame or any frame comes in with a bad SCS, we're going to call that bad. So I'll come over here and come back there. I should also note here, our remote collaboration stuff here, right? I'm remoting into both units through the management plane, actually through the Wi-Fi connectivity radio, while using the Ethernet port as the test plane, right? One of the things about our products is we try to have a separate management plane, either wired or Wi-Fi, so you're not Heisenberging your network under test as you're trying to measure it. So I'll go ahead and start this guy in loopback. He's going to start looking for a link. I'm going to start this guy. He's going to come in. He's linking. He's going to make sure, hey, I'm not going to blast a bunch of traffic into a switch and things like that. Okay, I got you. Loopback. Here we go. Now we're running along. And I'm going to wiggle my cable a little bit. And boom, there you can see errors. Right? It just from me physically moving that cable around. And so, industrial setting could be a conveyor belt, could be anything. But yeah, so you can kind of see how we've got this and we've got this trending, and I can even come down here and sort of be watching my, signal to noise ratios and delay skews and things like that. So that gives you an idea of how simple it is to run Lambert and then the interoperability of our products here. So,
James?
Yes, please.
I have a question. So how close do you need the cable to be away from the ESD to have a real impact on it?
Back to that, in fact, let me see if I can get back there now. Back to that Aquantia thing. They were showing the worst chair I think was the mesh chairs, and significant impulse noise. They were talking about somewhere in here with some distant stuff. yeah, the AP was 7 meters, 4 to 7 meters away, and you know, I think it just depends on the strength of the ESD, right? But you know, and it falls off as, you know, with a squared function, but yeah, so I would say. I thought there might be some more distant stuff in here. I'd have to go look through this thing again, but you know, I think you can have a pretty good air gap, right? You know, in this case, if it really was 7 meters and they were measuring it that far away. Oh, here, they could see this pulse at 5 meters in a Cat5e cabling. So yeah, you don't have to be right on top of it like my mixer. I guess would be the takeaway there. So
thank you.
And I did a lot of other testing in here, right? But I'm time boxed and trying to hold this segment to 30 minutes. So let me just try to close out on this part before I transition. So what's cool though is there's a lot of, you know, there is some forensics in the trending, right? Since we trend over, this is a trend over 24 hours. I should have had 24-hour screens here, but you know, you can kind of tell, hey, is it something that just turned on and off? Did it turn on every hour? Did it turn on once a day? Is it some sort of constant noise? Is it spurious and random, right? That'll at least give you some idea of what might be impairing your transmission. So the summary is you know, of course, if you pass certification and you pass our PERT at that speed, you know, awesome, that's great, right? And then there's the total fail case, both fail. But then there's this area here that I think this 95% of the cabling installed in the world kind of falls into, where if you brought in, you know, a cable installer and said, hey, am I going to be able to install my N-base-T things? They might say, well, no, you're not, because the cable doesn't pass the certification. But it had no problem. In fact, on those previous ones where I wasn't even passing gig, I was linking at 5 gig, 5G base T without errors, right? So it could have even dropped the clock rate in half to have even more margin. And then lastly, you might pass certification, right? Certification is a race of how fast can I certify this cable, right? Because you're installing a bunch of cables. So it's a 10-second test across the industry. And yet there could be some noise in your environment, right? And so that's where, you know, you can soak test a cable for 24 hours. So the summary is...
James, quick question. Can you go back to that other slide? Yeah, right there. So in your upper left, how do you manage that messaging? Because you're basically, unless I'm hearing wrong, you're basically saying ignore, you know, a couple of decades of relying on the tester as the final word. Yeah, how do you work in the nuance of, yeah, you're failing the cert, but, you know, it's actually the cable is okay. You know, that's a big pill for a lot of people to swallow, don't you think?
Well, I would say that, but the reality is I think there's just a misinterpretation of the standard. What certification says is every PHY in the universe, even the world's crappiest PHY, is going to run on top of this. If this cable meets these parametric standards, but I don't think the certification stuff has any clue what's happened on the DSP and the signal processing capabilities within these PHYs. You know what it really reminds me of? It reminds me of my rural broadband, right? When they pulled that cable 50 years ago, it was telco, right? You're getting voice, 4K tops, you know, on the filter, and you know, well, now I've got bonded DSL running over the same piece of wire, you know, and it's just, you know, we think about how modem speeds, you know, the negotiation, how that went up over time, right? It's just that they're kind of measuring the same characteristics of the cable, but the active network industry, I think, has just gotten so much better about with digital signal processing, you know, about managing this. So, yeah.
James, just to follow on to what Lee had said, I don't know if there's a lot of people who have a failed cert, but they have tons of cabling that may have had just a Cat5 cert 10 years, 15 years ago. What's the minimum equipment they would need to use Lambert to go back and test all their cable pairs, not with a cable tester, but with BERT instead, to see can they run multi-gig on it?
Yeah. So for under 10K, you can buy a 2-pack of Link Runner 10Gs, the new product we just came out with, and they'll do the circ for you. So, which could be the cost of just pulling 3 or 4 new cables. And of course you can use it, the next day for network discovery or auto test or capture at line rate or anything else, right? That it does. But yeah, so it's fairly economical too, right? And fairly straightforward to operate. I mean, personally, I've been blown away even trying to read the sheathing, right? It's like a decoder. There's no decoder ring for this stuff, right? Every vendor is labeling their it's really hard to know what you have. And when you really dig into it, there's even like sub vintages of, well, this manufacturer did this, then they tweaked that, right? And it didn't change it from a 5 to a 5e, but it did make it a little bit better, right? And so I think there's a lot to be said for application testing, as opposed to sort of this second derivative cable certification. I know it's a lot, right? But I'm kind of an empirical guy, and then, like I said, when I circled back with the one of the committee members for the IEEE, he said, "Oh no, there's this is certification is that any PHY will run through that. Doesn't mean that better PHYs can't run faster. It's just that every PHY must be capable of running it's like the minimum viable cable for everything to run at that speed." So anyway, so we spent a lot of time in the last year working on Lambert, and I got to start moving on. But it also will do fiber, right? In fact, here's an example of a single unit testing a strand of fiber. When you can physically loop it back, right? More often than not, you don't exceed the length on the fiber. You can validate. You're also even validating your SFPs. Kind of back to the question about switches earlier. At least you can get the SFPs as a part of the media test. 24 hours, all the other stuff we do. And that's that. So I'm going to try to close out this segment unless there's more questions.
Where did the name Lambert come from?
You know what? That's a great question. Actually, back in '97, I wanted to do this feature, and basically it didn't make sense at Fluke because they had a lot of their business in certification, and they didn't want to confuse the market. So back then, myself and Chris O'Dell were sitting in his office one day and said, "What are we going to call this thing?" And we decided Lambert because it's bit error rate BERT, but for LAN. So that's how we made up the name.
Bit error rate. I was missing that part. Yeah. Gotcha.